Hello and welcome to another episode of Earth911's Sustainability in Your Ear, and we are talking with Dr. Kenneth-Nealson, who's the Wrigley Chair in Environmental Studies and Professor of Earth Sciences and Biological Sciences at the University of Southern California. And he's also recently participated in the Wrigley Sustainability Prize. Ken, welcome to the show. How are you today?
I'm fine, thank you. Thanks for having me.
Well, tell us about the Wrigley Sustainability Prizes. You just recently awarded them just this month. Picked 3 companies. Why does the Wrigley Foundation do this, and who won?
Well, I'll tell you how the prize was born. We have at the Wrigley a group of about 20 advisory board members who have all the skills that most of us scientists lack, i.e. they're good communicators, they're good business people, they know how to get things across the lights. And one of our board members named Todd Bauer said, why don't, he's very closely involved with all of this pitch training that they do at the business school, to pitch an idea, to pitch a business, to do this. And he said, why don't we just put together a prize? And the board members came up with $15,000. And 3 years ago, we advertised this sustainability prize for undergraduates with ideas that pertain to sustainability. And we were overwhelmed. We had about 50 applicants. Out of those 50, we chose 6 or 7 finalists each year. And those finalists get mentored by this group of people at the business school, headed up by Todd Bauer, and then they get 5 minutes to make their pitch for the final competition. And I tell you, they're just like pros. But the more exciting thing is they have ideas that are just revolutionary sometimes and across the boards. So there's a $7,000 prize for first, $5,000 for second, and $3,000 for third. And I tell you, this year, I could have given the top 3 to any of the 7. I was just glad I was not a judge. So that's how it was born, and it's been tremendously successful. This year, we had 7 finalists, and the finalists were so darn good that we could almost not separate them. The group that won first prize were 2 chemistry students, and they came up with an idea to make a catalyst to free the carbon fibers from these fiber carbon bicycles and airplane wings and other things that are so hard to recycle. And they're having great success with it, and they want to take this catalytic invention and use it for recycling all of these very hard to recycle things that are filling up landfills now. A great idea, and when you realize it came from a couple of undergraduates that were working with one PhD student, it's just mind-boggling. It's great.
You're hitting on something about youth, I think, and that is that they see problems that we introduce in the course of business, such as carbon fiber, which is a tremendous innovation. Nobody thinks about how to recycle it; they build it.
No, this is the thing I love about this. One after another, these students come in, and they're thinking about stuff that the rest of us, when I was getting my education, we didn't know what a carbon fiber was.
Right.
And now these people are worried about there being too much of it and how to recycle it. So you're absolutely right. This is one of the big excitements of this, when we see these things come in. And I'll give you another example. A second prize group was a group of engineering students, and they were making artificial reefs by 3D printing and molding techniques. And the reefs have a lot of the same structure and potential function that actual reefs have. They want to put them out in places where the reefs are being stressed and use them for transplanting corals onto natural environments. Again, who the heck knew what a 3D printer was when I was going to school? And
I love the fact that they're printing ceramic four-legged creatures to stand in for coral.
Yes, isn't it wonderful?
It's artistically inspired too.
Yeah, and I'm just listening to these kids and smiling and saying, I don't know what I'm so worried about, because if we can just put these people in charge, things are going to be a heck of a lot better. So then the third group was a group from USC, partnership between a social work student and a communications major, and they've designed a mobile app so the students on campus can find out where there's excess food and free food. They call it Free Food USC app. Mm-hmm. And instead of throwing away food as food waste, they can go get it before it gets thrown away and have a free meal. Just a fantastic idea when they added up all of the stuff that they knew about the food on campus and saw how much they could save that wouldn't go to the landfill and would go to some food-stressed students. And it always seems there are some food-stressed students. Again, one of these wonderful ideas that none of us old folks would have thought about. And heck, who knew what an app was when you and I were going to school?
Who knew what a computer was? Well, actually, computers were things that white people in white lab coats ran.
Yeah, that's right.
So now let's talk about the Wrigley Marine Science Center out on Catalina Island, which is a phenomenal place. I've been out there years ago and saw near the when it was starting up. How they developed?
Well, I tell you, I came to USC about 18 years ago, and one of the reasons I came here was because the Wrigley family offered me a chaired professor position. Mm-hmm. And I immediately became part of the Wrigley family out on the island. Every one of my students has done part of their PhD thesis work out there. Mm-hmm. And I teach there every summer in an international geobiology course that we run. It's a haven of education during the summer and a great place for PhD students to do research under pristine ocean conditions. As I like to say, we're probably one of the few schools in the whole world that has an island. And the Wrigley Island is almost, except for the city of Avalon, it's almost uninhabited. So we may have the best 60 miles or so of pristine beach in all of Southern California.
Sure, 20 miles off the shore.
20 miles off the shore with a lot of water between us, almost a mile deep. And so it is a great place to do marine biology and marine geology. So when we decided to move towards sustainability on the island, there's a bit of a balancing act that needed to be done because there's so much good science that goes on there. And you have to add sustainability without taking away something else. And this has been what we've been up to for the last 3 years since I became director, how to put in a sustainability focus and still have the work on toxic algal blooms and ocean chemistry and ocean biology and marine microbiology that's first rate going on out there. And that way we keep the resource for the marine biology group here, but we add sustainability, which brings in the business school and all kinds of people involved with policy, et cetera. So it's an exciting time. We're adding a dimension to USC that wasn't here, and we're, if anything, improving the marine biology work that's going on there.
Now, your background is fascinating. I was reading about your early studies on the decomposition of magnesium, amongst other things, but you also were involved in the identification of life on other planets by how did you go from that to where you are today?
Well, it's a very interesting thing, Mitch. One of the discoveries we made early on when I was at the University of Wisconsin was that there were bacteria that could pass electrons to metals such as manganese and iron oxides. And these are insoluble, these metals are. And when you use them as an electron acceptor, it's just like what we do when we breathe oxygen. We breathe in the oxygen and breathe out the reduced oxygen. That's where the electrons went. And from that flow of electrons, we get all of our energy. So we call this breathing rocks, where these bacteria could actually swim up to a manganese oxide particle and use it for respiration. And at one meeting that I ran into with NASA, I made the offside comment. I said, take one look at Mars and all of those iron oxides on the surface, and you don't really have to worry that there's no oxygen up there. They have plenty of stuff to breathe. And the next thing I knew, NASA had offered me a job at the Jet Propulsion Lab to set up what's called an astrobiology group, whose one of their major functions is developing methods for life detection. And now, 20 years later, a little more than 20 years since I first went to JPL, one of my students has an instrument that he's building for the Mars 2020 mission to go to the red planet and do exactly that. So
wow.
This has been a heaven for me to be first at JPL and then down at USC with students who can do part of their thesis work now at JPL. And they do crazy things like invent new microscopes and do all kinds of things. So
now you currently work at the Wrigley Marine Science Center on the concepts of a coastal ocean process. That seems to be the underlying foundational theory of the approach that you all are taking on Catalina. How does that coastal ocean process relate to the way you have been thinking about the identification of life? And is our process in trouble?
Well, yeah, that's a very good question. It relates directly to it, but there's a little bit of a trap there. And the trap is that so many people who want to look for life on Mars or other planets want it to be just like life on our own planet. So what the Wrigley offers us is a way of testing a lot of our methods on a place that we know is alive. But the methods that we're using are not things that look for specific chemicals of life on Earth, because you just can't make the assumption that it's going to be the same. It could have a different kind of information. It could have different kinds of proteins. It could have different kinds of energy sources. So you have to ask very general questions. But since we're out at the marine station, we can take samples of seawater, some of which have very little in the way of life in them, especially if we go in deep into the sediments. And we can see if our methods actually work for detecting life. And we can test them with the methods that we know work on earthly life. So there's a nice connection there. And when we were testing the new microscope, we made good use of both what we would call the extreme environments in the marine sediments and the extreme environments out in the Mojave. And the great thing is we can say, doggone it, we know exactly how many bacteria are in those samples. Can we see them with the methods we're using that we want to fly to Mars?
Right. And the other thing that struck me as I was reading your background and about the winners is that biomimicry is obviously an increasingly important human insight into how we're going to solve our own problems. As you look at, and we were talking about how much things have changed in our lives, as you look at what's going to happen over the next 10 to 20 years in the fields of oceanography, biology, and so forth, what kind of opportunities do you identify for students, and what are you suggesting that they get into? What's your go west, young man?
Yeah, that's another great question, because the thing that I see right now, is interesting even today, before we started talking, I got 3 questions from students in email, and I get 2 or 3 a day saying, how the heck do I get into this sustainability thing? This looks really important. Mm-hmm. And the answer is a complex one, because sustainability is different in the eye of different beholders. You know, the businessman thinks about money, the scientists think about water and energy and the nexus of things we have to have science solutions for. And the policy people think about how to get everybody to say yes when we want to do it. And and then if you put the politicians into the mix, it gets even worse. But I think there's something there for everybody. And at a place like the Wrigley, we can start teaching courses in sustainability and let people make their own decisions and find the niche where they fit. And more importantly, we get them talking to each other. This is something traditionally that scientists have never been good at. We tend to stay in our labs and do our own experiments. This is a community issue here with the sustainability. And even a lot of the methods, I think, they're either going to be using biological systems, or as you suggest, there may be a lot of biological mimicry going on, where we see how the bacteria are doing something and then figure out how to either use them or make them be better at what they're doing by making an analog.
Well, and it seems like studying, for instance, deep sediment under the ocean surface is a place where we might discover biological processes that we would never have expected to take place on Earth.
Yeah. Yeah, you were so right about that, Mitch. I'll give you a very small example of that. One of the projects going on in my lab now is at a place in Northern California where a huge chunk of mantle rock, which should be a kilometer below the ocean, the sediment surface, sits up on top because of the way things happen when the plates collide. Mm-hmm. And this place, the rainwater percolates through it and comes out at a pH of about 12. And I went up there after I heard a geology lecture about this place, because according to what we know about life on Earth, nothing should be growing there.
Right.
And wouldn't you know it, it's full of bacteria. And so now we've been publishing papers with new species of bacteria, new groups of bacteria, and new things that bacteria do. And last year, now it's a year and a half ago, I was on a cruise on a Japanese drilling ship that drilled to basically a mile, a little more than 2 kilometers, a mile and a half probably, under the surface, the sediment surface of the ocean. So it went down 2,500 meters, and it took samples, and there were living bacteria there. We have no idea how they stay alive. There's almost nothing that we eat for them to eat down there, and nothing that bacteria on the surface of up here eat. So there's a whole host of things that are going to be discovered in the next I think, few decades. And it's one of these magic times when the technology is growing like crazy for things like deep sea drilling, and the technology for DNA analysis and life analysis is growing by leaps and bounds. The only thing that makes me unhappy is that I'm so doggone old, and all of this stuff is going to happen when I'm retired.
Well, it's nice to be able to read about, but I know what you mean about staying involved. Now,
yep, absolutely. And I hope as long as I'm healthy, I'll be involved here. And it just either as an old goat that comes in and makes trouble, or maybe even doing something useful.
So how does a student get involved in Wrigley, especially for somebody who's not at USC? Do you transfer to USC? Do you, and for instance, can you join the contest for the prizes if you're not a USC student?
Well, that is one way, and one of the things we talked about this year after the Wrigley Prize, because it's so successful, why don't we offer a second one where we expand it to undergraduates and graduate students, and include UCLA, Irvine, Riverside. There's a local base of excellent schools in Southern California. And we could make this a free-for-all by expanding the thing. We do have a program out on the island, which is called REU, Research Experience for Undergraduates, and that's an NSF-funded program, the National Science Foundation, and we take that program and advertise it across the country. And we get about 20 fantastic undergraduates every summer to come out. And from that group of 20, every year, several of them end up, when they choose a graduate school, coming here. And it's one of those programs that's magic. When I was at Wisconsin, we had one of those in lake biology. And now we've got one in ocean biology here. When a student discovers that their niche, they start working harder and get excited, and it changes their life. I also get inquiries on a regular basis about the possibility of coming here to graduate school, and I send them on to my friends that match the people that are writing them. And that's the stuff that's supposed to happen. And the best students know enough to write to somebody like me and just ask, how the heck do I do that?
Yeah, I don't think enough kids really understand that you can ask folks like you those questions.
You know, in the courses I teach, I tell my students that all the time. I say, you don't realize how insecure us professors are, and we love it when somebody asks us a question that we can actually answer. and I said, if you have a question, go to the top, ask the director, ask somebody, because to make their institute better, they want to attract the best students. And that's the way you make it better. So,
and the same is true in companies and organizations and policy organizations as well.
Yeah, isn't that the truth? Yeah. And so many. The best directors, the best leaders. That should be our number one target. How do we attract the very best young people? And I think right now that's an easy thing to do in the sustainability world, because lots of young people are thinking about it.
Well, that's a great place to almost wind this up. The last thing I wanted to ask you about is the USC Family Science Program, which also is another way that you can go visit Catalina and see and get involved in what you're doing. What is the USC Family Science Program in
there are a couple parts to it, Mitch. We have an active family, we call it the family science programs that happen in the summer, once in June and once in July. We run it for days at a time, and families can come out and join in. In some cases, it'll just be a one-day thing, but everybody participates. And these programs end up being really successful because lots of people return, and they ask us about coming out to the island. During the off season, we have housing that can be rented, and they can come out and enjoy Catalina, and also get some more insight into how research is being done and what's being done. And a lot of these people become friends of the Wrigley Institute. We call them the FOWI people, FOWI, and it's amazing how many of their kids end up going into science, and often doing it at USC. So,
well, that's fabulous. So, Ken Nealson, thank you very much for joining us.
This was a barrel of fun, Mitch, and good luck with everything.
Keep us surprised on what you're doing. Folks,
okay, will do. Bye-bye.
Take care. Folks, that was Ken Nealson. He's the Wrigley Chair in Environmental Studies and Professor of Earth Sciences at USC, as well as the leader of the Wrigley Sustainability Prize program this year. This is Earth911, Sustainability in Your Ear. I'm Mitch Ratcliffe, and we're going to be back with another innovator interview soon. Stay tuned and take care.